In this video, we will uncover hidden trends and patterns in Airbnb data that can revolutionize the way you host or travel. From pricing strategies to understanding guest preferences, we have got it all covered. Let's embark on this. First, we import essential libraries to kickstart our data analysis project. These libraries provide us with the tools and functions we need to work with data, visualize insights, and create meaningful conclusions. We import the NumPy library as NP. NumPy is a fundamental library for numerical and mathematical operations which will be helpful for data manipulation. We import the Pandas library as PD. Pandas is a powerful data analysis and manipulation library that allows us to work with structured data effectively. We import Matplotlib.pyplot module as PLT. Matplotlib is a popular library for creating static, interactive, and animated visualizations in Python. We import the Seaborn library as SNS. Seaborn is built on top of Matplotlib and provides a high-level interface for creating aesthetically pleasing statistical graphics. We import the Plotly Express library as PX. Plotly Express is a versatile library for creating interactive visualizations and dashboards. It's excellent for exploratory data analysis and presentation. This data analysis projects can sometimes generate warning messages, which may not necessarily be errors but could clutter our output. To ensure a clean and focused analysis, we are using the warnings library in Python to filter and ignore these warning messages. This way, our analysis output remains clear and uncluttered, making it easier to identify meaningful insights and trends. Warnings can be helpful during code development, but this can be distracting when presenting our findings. With this simple addition, we are optimizing our analysis environment for a smoother and more organized data exploration process. We have just loaded our Airbnb dataset, which is stored in our CSV file named airbnbprices.csv into Pandas data frame. This dataset is a treasure trove of information about Airbnb listings, which with columns providing details such as room type, location, pricing, and more. Now let's take a closer look at this dataset to find key insights. Here, by using the info method, we have gained valuable insights into the structure of our dataset. Our dataset contains a total of 18,723 entries. Some columns have missing values denoted by the non-null count information. For instance, the country, borough, bathrooms, min stay, and name columns have missing data points. We can also observe the data types for each column. We have columns with float data type, int data type, and object data type, which represents string or textual data. This summary helps us understand the size of our dataset and identify any potential data quality issues. It's crucial first step in our data analysis as it guides us on how to handle missing values, choose appropriate data types, and perform further exploratory data analysis. Let's move forward and uncover more insights from our dataset. Here axis is equals to 1. This parameter specifies that we are removing columns with missing values, and in place is equals to true. This parameter allows us to modify the dataset in place, which means we are directly applying this change to our dataset and we don't need to create a new data frame. By eliminating columns that have missing values, we are streamlining our dataset for analysis. This is just one of the data cleaning steps to ensure the quality and reliability of our findings. Now we have more robust dataset to work with in our data analysis. First, we checked for duplicate rows in our dataset to ensure data integrity. Here number of duplicate rows came as 0. Dataset is clean from duplicate entries, ensuring that each row represents a unique Airbnb listing. This step is essential for accurate analysis. After confirming that our dataset is duplicate free, we move on to next step, which is outlier detection. We have created a box plot to visualize the distribution of prices for Airbnb listings. In the box plot, we can identify potential outliers as data points that fall significantly above or below the whiskers of the box. Outliers can be valuable in identifying unique listings or anomalies in pricing. The price column is a crucial factor in our analysis, and identifying outliers will help us understand pricing variations. In our box plot, we can see that a majority of data points are clustered within the range defined by the box and whiskers. This range represents the interquartile range. Most of Airbnb listing prices falls. The outliers represented by data points outside this range may indicate luxury or special listings that are priced significantly higher than the average. These outliers can provide valuable insights into unique offerings in the Airbnb market. Having completed our initial data cleaning and outlier detection steps, we have now saved the cleaned dataset to a new CSV file named cleaned_dataset.csv. This cleaned dataset is ready for further analysis, ensuring that we are working with accurate and reliable data. Then we calculated earnings per host. So, by grouping the dataset based on host ID and summing the price for each host, we obtain a clear picture of total earnings for each host. This information helps us recognize the most successful hosts. Identifying top earners is not only interesting but can also provide insights into what makes these hosts stand out. It's one of the ways we are exploring the dynamics of the ecosystem of Airbnb. Next, to obtain monthly earnings, we have multiplied the price for each listing by 30, assuming an average month of 30 days. This allows us to standardize the earnings and make meaningful comparisons. We have also calculated some key statistics to understand the distribution of monthly earnings across all listings. These include average monthly earnings, total monthly earnings across all listings, as well as maximum and minimum monthly earnings. And these are the hosts who have generated highest monthly earnings. To gain a better understanding of Airbnb landscape, we have created a crosstab. This table allows us to examine the occurrences of different room types within each neighborhood. In our analysis, we have taken neighborhood and room type as our focus. The crosstab provides a clear view of how many listings of each room type are available in every neighborhood. To explore the distribution of room types across neighborhoods, we have generated a heat map. Each cell in the heat map represents the count of specific room type in a given neighborhood. The color intensity varies from light to dark, with darker color indicating a high amount of that room type. The variations in color intensity across heat map reveal interesting patterns. Some neighborhoods seem to specialize in certain room types, which could be influenced by cultural, economic, or maybe zoning differences. This insight can have implications for pricing, demand, and occupancy rates, affecting the experience of both host and guest in the city. One of the key metrics we have examined is total number of reviews for each neighborhood. Reviews are a valuable source of information for both travelers and hosts. They reflect the experiences and satisfaction levels of guests in specific neighborhood. After analyzing the data, we have discovered that this particular neighborhood stands out with the highest number of reviews. This indicates that it's a popular destination among Airbnb guests. For travelers, this information can be helpful indicator of neighborhoods that have received positive feedback from previous visitors. Hosts in this neighborhood may also find it valuable as it suggests a high level of interest and activity, potentially leading to increased bookings. Then we imported the great circle function from geopy.distance module, which will be helpful for calculating distances between geographical coordinates. We have established a central reference point using the geographical coordinates of Airbnb listings. We calculated the reference latitude and reference longitude by taking the means of all latitude and longitude values in our dataset. In this function, we extract the latitude and longitude of each listing. We then use the great circle function to calculate distance in kilometers between the listing's location and our reference point. This reference point is a central coordinate that we have set as basis for our geographic analysis. Then we have aggregated our data to create a new data frame called neighborhood stats. In this data frame, each row represents a unique neighborhood, and we have computed several key statistics for each neighborhood. The price column in our dataset indicates the average price of the listings. In neighborhood stats, we have calculated the mean price for each neighborhood. This gives a sense of typical price range within each area. The overall satisfaction column reflects the average customer satisfaction score for each listing. In our new data frame, we have also computed the mean satisfaction score for each neighborhood. This tells us how guests generally rate their experiences in different areas. The accommodates column indicates the average number of guests a property can accommodate. Once again, we have calculated the mean number of accommodated guests for each neighborhood, helping us understand the typical capacity of listings in different areas. Creation of neighborhood stats allows us to easily compare and analyze these important metrics across neighborhoods. In this bar plot, we have each neighborhood along the y-axis and average price on the x-axis. The varying bar lengths represent average price in each neighborhood. What's striking here is diversity in pricing. Some neighborhoods have notably higher average prices while others are more budget friendly. For guests, understanding these price variation is crucial for making decisions. It can influence the budget and overall experience during their stay. But why do these differences exist? Neighborhoods with higher price might be closer to popular attractions, offer enhanced safety, feature and aesthetically appealing surroundings, hold historical significance, or boast community amenities. Understanding the level of guest satisfaction in different neighborhoods can be a game changer. This bar chart visualize the proportion of highly rated listings in each neighborhood, helping traveler make informed decision about where to stay. Each neighborhood is represented on y-axis and the proportion of highly rated listings on the x-axis. A highly rated listing is defined as one with the overall satisfaction rating of 4.5 or above. What's immediately noticeable is the variation in guest satisfaction across neighborhoods. Some areas have high production of highly rated listings while others have fewer. As a traveler, this information can significantly impact your experience during your stay. For travelers seeking a top notch experience, neighborhoods with a high proportion of highly rated listings might be a preferred choice. It suggests that guests have consistently enjoyed their stays in those areas. On the other hand, for potential hosts, identifying areas with lower guest satisfaction may represent opportunities for improvement and differentiation in the market. It's a valuable insight for hosts looking to enhance their guest experiences. Folium. Folium is a fantastic library for creating interactive maps. It allows us to visualize geographical data and explore spatial relationships within our dataset. K-means clustering is a powerful machine learning technique for grouping data points into clusters based on similarity. In our context, it can help us identify patterns in Airbnb listings. But before we proceed, we need to handle categorical data. That's where label encoder comes into play. It transforms the categorical values into numerical representations, making them usable in our analysis. Now let's connect the dots. We will use k-means clustering to group Airbnb listings based on various features like location, price, and more. This can help us identify clusters of similar listings. Once we have applied clustering, we can visualize these clusters using Folium. This creates interactive map that allows us to explore how listings are distributed across different neighborhoods. Now we are about to create an interactive map with clusters. This map visualizes the geographical distribution of Airbnb listings. We will use k-means clustering to group these listings based on their geographical coordinates and guest satisfaction levels. But first, we need to convert overall satisfaction ratings into categorical values. We are using a mapping to translate the ratings into five categories from highly satisfied to highly dissatisfied. Label encoder come into handy again. It assigns numerical values to these categories so they can be processed by k-means algorithm. Now we are setting stage for our clustering analysis. We have chosen four clusters to group our listings. Each cluster might represent different kind of neighborhood or area. The colors for each cluster are red, blue, yellow, and white. We are using Folium to create an interactive map that's centered on the mean latitude and longitude of our listings. Now, pay attention to the circles on the map. They represent individual Airbnb listings and their colors correspond to cluster they belong to. The size of circle helps you visualize the spatial distribution of listings. As you hover over a circle, you will see a pop-up that displays the cluster number and the guest satisfaction level. The beauty of this map is that it helps traveler discover areas that align with their preferences and gives host insight into their characteristics. We are saving this interactive map as an HTML file to explore on your own or to share with others who might find it useful. In this visualization, we have conducted a categorical data analysis to better understand the distribution of Airbnb listings based on room types. On the x-axis, we have different room types. These can include entire home or apartment, private room, or shared room. The y-axis represents count of listings falling into each room type category. As you can see, entire home or apartment and private room are the most prevalent room types. This suggests that most listings are either entire homes or private rooms available to guests. In our Airbnb data analysis project, we have conducted a t-test to compare the overall satisfaction ratings between two different room types, entire home apartment and private room. So we start by defining our two groups for comparison, and these are the common room types on Airbnb. The null hypothesis in our test is that there is no significant difference in guest satisfaction between these two room types. In other words, if the null hypothesis were true, the guest satisfaction ratings for entire home and private room would be the same. The T statistic is a measure of how different these two groups are. In our case, T statistic is approximately minus 6.82. The p value is a crucial component in a hypothesis testing. It measures the probability of obtaining results as extreme as the ones observed in the sample data. Assuming null hypothesis is true, in our case, p-value is approximately 9.12 exponentially to the rate of minus 12, which is an extremely small value. With such a small p-value, we have strong evidence to reject the null hypothesis. It suggests that there is significant difference in guest satisfaction between different room types. The negative p value implies that on average, guests tend to be less satisfied with the entire home or apartment listing compared to private room listings in the dataset. These insights can be valuable for both host and guest. Host can adjust their offerings and pricing based on guest satisfaction. In our Airbnb data analysis, we are interested in understanding the factors that influence the overall satisfaction of guests staying in those listings. To do this, we have calculated the correlations between the overall satisfaction rating and various numerical factors in the dataset. Host can focus on improving factors related to cluster and satisfaction categories to enhance guest satisfaction. We wanted to investigate if there's a significant difference in guest satisfaction ratings across different room types. To do this, we performed ANOVA test, which is an analysis of variance test, which helps us understand whether there's a statistically significant variation in satisfaction scores among groups. ANOVA test yielded an F value of approximately 71.10, an extremely low p value of about 1.94 to the rate exponential to the rate of minus 31. A low p value indicates that there is indeed a significant difference in satisfaction scores among the different room types. To get a clearer picture, we also calculated the average satisfaction scores for each room type, and entire home or apartment have the highest average satisfaction score, standing at approximately 4.78. This suggests that guests staying in entire home or apartment tend to have the best experiences. Host can consider focusing on providing entire home or private room to cater to guest preferences for comfort and privacy, which tend to receive higher satisfaction ratings. Here, this scatter plot showcases the distribution of data points for each listing, with price on x-axis and overall satisfaction score on the y-axis. Each point is color coded based on the room type, helping us understand how different room types are distributed across price and satisfaction. Our analysis revealed that price is indeed a critical factor that influences overall satisfaction. However, it's not the sole determining factor. A more nuanced interpretation is needed since guest satisfaction is influenced by various aspects of the Airbnb experience, including room quality, location, amenities, and host interactions. The correlation between overall satisfaction and price is relatively weak, which is correlation coefficient of approximately 0.095. This indicates that while there is a positive relationship between price and satisfaction, it's not a very strong one. In simpler terms, paying more for a listing does not guarantee a significantly more satisfying experience. We aim to uncover the factors that influence Airbnb prices and room capacities in different locations. We start by visualizing the geographical distribution of prices in the area. The map displays the latitude and longitude coordinates of Airbnb listings in our dataset. Each point represents a listing and its size and color represent the price. Larger and warmer colored points indicate higher prices. What's evident from the map is that location plays a pivotal role in determining prices. Listings in certain areas are consistently more expensive than those in other locations. This reflects the real estate axiom that location is paramount when it comes to pricing. The second part of our analysis delves into accommodates variable, which tells us maximum number of guests a listing can accommodate. We first conduct an analysis of variance test to examine whether accommodate significantly differs across different room types. The ANOVA test yields a high F value and a very low P value, suggesting that there is significant difference in accommodates across different room types. Further, we compute average accommodates by room type, and entire home or apartment and shared room listings have high accommodate average accommodates, indicating that they can accommodate more guests. Private room listings accommodate fewer guests on average, likely due to their more limited space, often providing just one room.